Okay, so here's a quick demo of how this SAM-DEV developer box here works. Let's just take a look at sort of the hardware here. So we have the deck box sitting right here, the white thing. There's a lid you can put on top of it. It comes closed up, and you can open it up, of course, with screws or just put some tape on it. Then this thing is the dongle, the JTAG, to connect to the Texas Instrument development system. You can see how it's plugged into a connector right here. The ribbon cable here is a status LED that you see lit up right now. I'll get back to that later. There's two sonar transducer connectors. Only one is equipped. You only need this one here. So notice that it's on the left. The one on the right doesn't have any wire going to it. And then we have this thing that's meant to be normally for the dev box like an on switch. You switch it on or off. It's really a momentary push button switch. It's not coded in right now. This is also when you're going to the payload section for the CTAG mod, then this is actually the on payload on signal, which would normally be used by the main tag to ask the payload section to do something. The return signal payload event, which comes back from the payload section to the CTAG, unfortunately isn't there's no pinout here available for that. So it's not the ideal environment, but it's pretty close. Right now we have the USB connector here hooked up, and we have a terminal program running Teraterm 115200 baud, and I'm running the FFT signal detector right now. Then here on the floor right now we have this white transducer. That's the one that I'm going to ship you here. It can be used as a hydrophone up to about 125 kilohertz, and right now I'm just using one of our sort of 34 kilohertz transducers hooked up to a signal generator here to put a signal into it. Let's just see what's happening here. Right now we have a signal here of 5 kilohertz. And then you see this number 1 here. You'll have to look that up in the code. That is right now the 5 kilohertz frequency. You can actually see it here. Now if I can focus that, okay. 5 kilohertz here right now. And I can move this around a bit to a higher frequency wherever. See how that's now up here. And what does it say? 17.968. And here we are at 18.070, so it's in the same bin here. So you can see how that works, and in a similar way you could code something up then that's more suitable for your thing. I also coded it up so that the LED comes on if it detects a tonal signal over a certain persistence. Right now I set it up for like 10 of these reporting lines, and now I'll switch the signal generator off and the LED goes off. And here the power level, PT, power total, is down. It's just tens to hundreds, and then when I switch it on, after a while, after 10 reports, the LED comes on again. So this is just for you sort of as a sample application and how to deal with all that. And we went through all the connections that are really relevant. There's a couple connectors here that are not used for your work, so they're not equipped here right now. All right, here's a quick demo as to how to compile, install, and run an app on SAM-DEV on the developers unit. So here is the IDE, the Code Composer Studio from Texas Instruments, and I happen to be in the main.cpp right now. You can see the structure of it. It starts out, does some initialization here. You can look that up. Then here's a little for loop, and it just blinks the LED green, red. And then I just have it, I commented out a bunch of stuff, and it just goes into self-test here. right? So if I want to compile it, I can do build all, right? Build finished. And now what I can do is actually what I want to do is, well, let's do first load it. We can load the program. Actually, I think I have the old one running here. All right, now I'm going to do project run. Well, I'm going to go to debug mode. Let me do that. So now this shows up, this pop up, and now stuff is being downloaded through the dongle here. Okay, and now you can see it started the program and then it stopped here at the beginning of main. And what I want to do now, just to show what happens when I start it, I'm going to call up TerraTerm serial COM5. That's the port to the developer box. And then I have to go set up serial port, and we're communicating at 115,200 baud. There we go. And let's see if I can put this side by side. Here you can kind of see it. Here should almost work here. Maybe make this a bit taller. And then when I go to run, resume, then it actually starts running the program, and we should see the green red message, and the LED is blinking there too. And now we are in self-test mode. So at this point here, I can terminate. That terminates the debug session. The code will keep running. You could have also set breakpoints and all the stuff that you can normally do in an IDE. Yeah, I just hit the question mark to get my menu again. And now we'll go back to the FFT signal detector, what I showed you before in the first part of the video. Here I'm going to set a sample frequency of 100,000 hertz. A duty cycle, I'm only going to take like every 1 in every 100 FFT results. So one FFT here is 256 points, so I just don't want it to be flying off the screen. A low frequency boundary of 1000 hertz. I don't want to get the DC component right now. High frequency boundary, well, Nyquist is at 50,000. Why don't we go there? 50,000. Spectral concentration threshold 2%. So we're going to light up the LED if 50% of the energy is in not more than 2% of the bins. Persistence 10 reports is what we had before. Power detection threshold 1000 maybe. And now we have this going on, and it shows us where the energy is. There's right now very little power. The signal generator is off right now. Now the signal generator is on, and we get this here now, and the LED is now lighting up because our spectral concentration is even 0%. It says it's really everything is in one bin right now. It says at 7,812 hertz, and my signal generator says 7,875. Let me just change the frequency a bit. There you go. Now we're at 10,500, and then max it out for me. 22.6. I see some 22.6 is the peak. It seems to be picking up some harmonic here, up here. So now the harmonic is gone. I don't know exactly what the sensitivity setting is for the 0-1 display here. So anyway, that gives you the idea how to operate this. Let me go back to the dev environment, and I could now say I terminated, remember that? So I'm going to just say debug again, proceed. See, now the display here stopped in tera term, because now new code is being flashed here. Okay, and here we are. It's at the beginning of main, and run, resume, and here we see our green, red, 0, 1, and our self-test and so on. So that's how you do some basic code. You could have done some editing, downloading, running it, see how that all works. All right, have fun with it. That's the end of the demo.